Hi everyone, I think we can start. Just let me try the slide, okay. So we are Elysium Lab. We are a startup based in Lugano, and we are developing a keyless authentication system for Bitcoin application. There is me, I'm Aron. There is also Gianmarco, we are the founder. And yeah, today we are discussing about the Bitcoin keyless future. Bitcoin is really cool, you know, it's a great technology, but even today it's just for nerds. And this is probably the main problem of mass adoption that can scale globally today. And there are many tools that can do something, but not everything. And especially in countries where Bitcoin is not strictly needed, people think maybe it's a scam. I trust maybe the francs more than Bitcoin or the euro or the dollar. And maybe it's used to buy drugs and whatever. And people are ignoring those benefits because the benefit is huge. And Bitcoin deserves the masses as the masses deserve Bitcoin. If we compare internet with Bitcoin, internet, even if it was older, with less tools and even more expensive to buy, like the machine, the computer, and everything else, had really more users after 15 years from the launch compared to Bitcoin. So this is the wallet of Satoshi. Maybe people know the banking IBAN, but when they see that, they think, what the fuck is this? If I lose this, I lose my money? Yes. Oh, fuck. And yeah, this is a really great, a big problem for normal people that have no technical background to onboard in Bitcoin. Not your keys, not your keys, not your coin, that's for sure. But then, how do I secure my keys? You can see just a few data here in this slide. You don't have to read everything. But the problem in general are in the custody side and the authentication side. That is the first stop for people. People are losing their data, their keys, their funds, their identity. And nowadays, with more threats that are coming, it's even more difficult to stay protected. And the general problem that we are fighting with, in Elysium especially, are the onboarding complexity and recovery of the account, the identity that is not connected with people, the technical asset management, and the incompatibility of Bitcoin assets or stablecoin, and in general, the management, and the cyber attacks that have multiple surface of attacks. And of course, we want also to fight centralization of data, funds, and keys in general. So if we want to study a threat model in our space, especially in our space where we have the authentication system and our own wallet for Bitcoin and stablecoin and all the layer of Bitcoin, there are three pillars of risk parties. The first one is the users. It's me, it's you. You can make mistake, of course. There is the company, the product owner, so who is making the product is a legal entity also. And then we have the third pillar, that is the infrastructures, the tech stack, and the intermediaries to run the product and connect product user and so on. And I would like to analyze every one of these pillars to make you understand what are the risks you are exposed in general using a product in our space. But this could be applied also in general. This is more security side. So first of all, people make mistake. You can control the people mistake. It probably is the weak chain of the weak ring of the chain, and people are exposed to human error, like loss of keys, lack of backup, inadequate key management in general. They are exposed to phishing, and the phishing are really improving with AI, deepfake, and so on. Of course, malware and virus like keylogger, cryptolocker, AI, SID, and QR recognition if you have a virus in the computer or on the phone, fake wallet or compromises hardware, and so on. This, of course, for people is a real damage for loss of funds, loss of data, violation of identity, and so on. And the solution we have for those problems maybe are not so great up to date, but is of course education and awareness, biometric solutions that are more connected with the identity of the people, hardware tokens, so like cold storage or hardware token for access security, and having improved security in the wallet. But of course, improving the security make the usability lower. Then we have the company, that is a central point of failure. And of course, companies are made of people. So you also have the problem of the people before. And the risk of company are the same as keylogger, cryptolocker, spoofing, food, and lack of data. We have internal malicious like people that have a wrong access to data and security, social engineering to the company, phishing campaign, and we have also, as a legal company or an entity, we have censorship problem. For example, if you want to communicate something and you have FAT censorship, listing products is difficult if you are in a certain topic. We can say, for example, Proton Mail, that if you want to find their product on Google, you find them in the third page of Google, even if it's the one of main privacy product seller. And this is thanks to Google that have the monopoly, like Apple, Google, and so on, that can make your ranking lower. And the same is with media, mainstream media, and so on. And of course, you have to fight with compliance. I can guarantee you, we have a Swiss company, and even if we have a Swiss company, we are struggling always with legal, IML, compliance, KIC, and so on. Because you have to remember that, for example, even in Switzerland, there is FINMA that is super advanced in some cases, but is still led by banks. And banks don't like us as we would like to be. The solution for the company are, of course, running regular security audits, implement cold storage for the custody or advanced custody solution with a hard gap, internet gap, disaster recovery plan, of course, and we have also the security testing on people. We also run a phishing campaign inside the company to train guys to not be a lack of security. And of course, you have to follow regulation. So you have to mitigate this risk, speaking with the authorities. Sometimes this is a trade-off, but you have to, because otherwise it's not possible. The third one is the infrastructures. The infra stack can suck. It's like a puzzle, and you have to choose the right pieces of your technology stack. And yeah, the risk that you have, offline services and all the, if you think about the API and all the infrastructure stack that you have in the product, can cause a waterfall damage on your product, and not only yours. This can really cause an ecosystem damage, not only for you, but all for the ecosystem around. If you think about Azure from Microsoft, Infura from the nodes, and this is also a problem for centralization of nodes and mining power, for example, like the pools and so on. That's not a really decentralized solution. So when you want to build a really resilient and secure security stack, you have to decentralize the player that you are implementing, the API and the services. And even if cloud storage, cloud computing is super scalable, having a secret local storage, or at least computing of something, could be even good. Not only cloud system, but hybrid solution could be even scalable and secure enough. The risk they have, of course, is also zero-day bugs, outdated libraries, public libraries that can be compromised, attacks, and manipulation of data in libraries. We can use the solution as making partnership with providers, so you have high priority with things that you are implementing, like ESP and so on, backup and recovery, and active monitoring. So you always have a plan B from your stack sources. And yeah, we call this problem the Elysium trilemma, or the trilemma of a product, we can say. What we are doing is position Elysium in a really usable and secure spot where you can actually manage your authentication, mitigating all this risk. You will find more information with Gianmarco now. This is my last slide, but actually is connecting your product, or in this case Elysium, with something that you know, something that you have, and something that you are, and you can position yourself inside this trilemma to mitigate all the risk exposure from a company point of view, from a user point of view, and from a tech point of view, because we don't want to create any single point of failure. You cannot lose your keys, you cannot have the knowledge to manage your keys. And just something that I think is fun, when we test our product, we test it with our security expert and hacker and my mom, because it should be simple enough for my mom and secure enough for our security expert. And now is the time of Gianmarco.
Okay, thank you very much, Aron, for the presentation. So now we'll try to go a little bit deeper into basically like the solution, what we think is the solution, and what we do as a company. So basically, just from a high-level perspective, we at Elysium are trying to work to make Bitcoin accessible for everybody, as you were saying, for his mother, but also for security experts. And the way we're trying to do it is by letting Bitcoin stay non-custodial, because actually Bitcoin was born to be non-custodial, and that's the way we think Bitcoin should be, and non-custodied by banks. We're doing that by creating a technology that try to extract the complexity of key management, because we know it's actually a pain, by basically connecting the cryptographic key that you create and you have to have in this space to start working with Bitcoin to the user itself. And we will see it later. So I will try to go deeper into three main pillars that we think are the most important for our technology. So the first one is the seed phrase. I guess you all are quite familiar with what is the seed phrase, but just want to go a little bit more deeper into how it works from a technical perspective, what kind of solution there are in the market to make it a little bit better and how to use it better, and what kind of problems seed phrase bring with them. Then we will go and we will deep into what is the entropy. It's to me is one of the most interesting concepts in life in general, and see how entropy is that much important when we are creating seed phrase, and then we will dive deeper into what is a factor. In the 21st century, and how we can use factor to make the Bitcoin experience a little bit better. So just really high level perspective. So what is a seed phrase? As I said, I guess you're all quite familiar, but a seed phrase is actually the human readable representation of the cryptographic key that we use to enter the Bitcoin space. Why do we use it and why we need it? So first of all, it's how we generate an account. So it's actually your on-chain identity. We use it to sign transaction, and we use it also to restore your account in case maybe you lose your phone or maybe you lose access to it. How in general, like normal wallets generate it. These are like 5 steps, really high level, but the overall idea is that we generate entropy. We'll dive deeper later what is actually entropy. We create a checksum that is just a way to protect the user to not maybe misspell some words. We append the checksum to the entropy. We divide it by 11 bit. I mean, this is really technical stuff. And at the end, what we have is we map every segment that we generate from this number to a word list of 2048 words that are basically the BIP39. So everybody of you, if you have a seed phrase, actually using BIP39 to access this word. What you get is basically this. So 12 words, 12, 24 words, depending on what kind of bit you're using. But the overall idea is that you get this, right? So this is your cryptographic key. This is how you enter the space. And at the foundation of a seed phrase, what we have, so this word seed phrase really means numbers. So seed phrase and private keys are just numbers, nothing crazy. We can see as hexadecimal numbers. We can see as bytes in general if you are a computer. And the question now is how we can use seed phrase in a better way. Seed phrase has some weak points. Seed phrase in general is a single factor, so if you lose that, you potentially lose all your funds. It's vulnerable to theft, loss, and also damage, because potentially somebody can kidnap you and try to steal your seed phrase, or potentially if you store the seed phrase on a piece of paper and then some water or some milk goes on that, basically you lose your funds. So as we can see, it's a single point of failure. It's not actually the way that we want the Bitcoin in general, but this interesting to go with, and also difficult to memorize, because of course we have so we as humans are better to remember words than numbers, but at the same time, like 12 words without really a meaning on that is really difficult to remember. And so there are some questions that we're trying to answer. In general, how we can create it in a better way. How we can we actually distribute the liabilities of the seed phrase over many places? So the thing is, it's single point of failure. So the second and the third question are kind of the same, like how we can delete the single point of failure when managing seed phrase. And then while doing that, can we also try to limit the attack surface of basically the seed phrase itself and on us as human beings. There are some options in the market. There's multi-signature, there's M2C, and so multi-party computation, and there's also threshold. So there are quite a few potential solutions in the market. Let's try to dive a little bit deeper into how they work. So from what is multi-signature? I guess still you guys are quite familiar, but let's try to go a little bit deeper. So the concept of multi-signature is it actually requires multiple signatures to authorize a transaction. The implementation is really straightforward. So you get M out of N, basically a scheme. So you have 2 out of 3, 3 out of 5, depending of what kind of implementation you want. But the real idea is that each single signer has their own private seed phrase, and it's really not that easy to cooperate and do something like this. So overall, this is a really easy scheme to understand how basically setup of a multi-signature works. So you have a backup key in case you lose one of the other two. You have a wallet owner, or in general the first one in the first person that tried to initiate the transaction, and then you have a co-signer that is signing the other one, authorizing the actual transaction. You met the threshold, so you met the 2 out of 3, and basically your Bitcoin are gone and the transaction is broadcast to the network. Multi-sig is cool. It's actually have some benefits. So you actually distribute the trust among multiple parties. So it's better. We don't have a single point of failure. But at the same time, has some challenges. We do have increased complexity in the setup. So you need to cooperate to actually sign a transaction. And if you lose maybe 2 out of the 3 seed phrase, then actually the threshold is not met, and you basically can lose all your funds. Another option is the multi-party computation. Is getting a little bit more popular the next few years, and it's basically like a cryptographic technique to compute distributed and encrypted data. So basically, you're not computing locally, but you're computing in a distributed manner. The implementation is basically the seed phrase is created and is split into shares, and those shares are actually held by some other actors. Are really never reconstruct. So the seed phrase at all is never reconstructing full. And basically, as I said, like each single party holds a part of a share, and they all cooperate to sign the transaction. Really high-level scheme of how it works. So basically, when you create a key, you actually share, you divide it into share, and you share actually with other players. And when you want to sign it, you need everybody to actually cooperate, sign it, recreate the key, sign a transaction, and that's basically it. Also, multi-party computation has quite a few benefits. So there is no single point of failure. That's actually something that we want. There is more security and more privacy, and that has also, like, similar to multi-signature, we do have some multiple threshold settings, like 2 out of 3, 3 out of 5, etc. But still, we have some challenges also in that perspective. So we do have computation overhead. So you do require active participation of the user. So every single user must be online to actually recreate the key signing transaction and then broadcast it. The third concept is the third option is the threshold signature scheme. A little bit, it's a cryptographic primitive. It's quite new, and we are seeing actually the first implementation in the market, but the overall idea is that you have a distributed key generation and signing. It combines part of the multi-signature scheme plus the multi-party computation, and in general, what you do is you create a public key from a distributed private key shares. The benefits are, for sure, you have more efficient than traditional multisig. It has enhanced security, but still you also have some flexible thresholds, so quite something that we want. But at the same time, there are some challenges. So it's relatively new as a technology. We're still seeing the first implementation, but it requires a lot of careful implementation to ensure that it's actually secure. So now that we know and we have some alternatives on how to manage, like, let's say, single seed phrase, so we do have multi-signature, we then have multi-sig and threshold. The question is, how can we make it better? And let's try to do a step back. So we said earlier that when you create a seed phrase, you're creating entropy to actually created in general the seed phrase, so what you actually use to enter in the space. But the question is, what is actually entropy? And to me, entropy is one of the most important concepts in life, because we do have two things. We do have order, so we try as humans to have order in our life, but at the same time, when we are talking about in general computer science, the concept of randomness is really important. So a simple definition of what is entropy: the entropy is basically like the quantitative measure of disorder or randomness that we have on a system. And so the idea is how unpredictable the output of a specific function is in a specific system. Let's say this room is quite it has low entropy because every single chair is in a specific place, but if we all try to stand up and just mix it up, it's probably going to be a little bit more high entropy. So that's what we want. And so this is actually the difference between low entropy and high entropy. What we do want, and what actually entropy is in an IT and cryptography system, is actually the degree of uncertainty and unpredictability over some set of data. So the set of data that I receive are actually unpredictable, or can I have a way to actually recreate the same output from the input that I have? And the key aspects of the entropy is, what we want is high entropy. So the higher the entropy, the greater the unpredictability of a system, and so the stronger a security of a system is. The overall idea is that the expectation of us as human beings is that we want to have true randomness, but the true randomness as a concept is not something that is that exists in real life. So what we do have in reality is that we basically rely on a randomness that is basically computation unfeasible for an attacker to predict. What it means is that if we assume that an attacker has infinite computational power, well, every single algorithm that we have nowadays will be basically doomed. But the assumption that we have is that our basically attacker has a limited amount of power, and so it's impossible for him to actually compute and predict the output of a specific function. Generally speaking, how normal wallets generate seed phrase are through this algorithm. So it's called cryptographic secure pseudo-random number generation, quite long. And it's basically like an algorithm where you create random and cryptographically, basically random numbers and cryptographically secure numbers that appears to be random, but are not, as we said, as full, like true numbers, depending on the system that we're talking about. The key feature of this algorithm is we do have unpredictability, so you cannot predict what is going to be the next output. It's not repeatable, so even if you know part of the sequence and the numbers that were generated at first, you still have no idea what's going to be the next one, and it's actually independent from the seed itself. So the information and the input that we receive are not really shown into the final number. In general, these are the first step. I'm going to present it really quick. The first step on how, like a normal mobile wallet, and generate entropy. So there's the first step, that is the entropy collection. You basically have multiple places where you can find entropy and can find information to then create entropy. We do have hardware sensor like accelerometer, gyroscope, microphone, many other things. We do have user interaction, so we do have touch events of the user, key press, and in general something that the user does in the device itself. And we do have system data, so system out of the battery level, network statistics. So in general, as you can see, are all things connected to the device. And the overall idea is that all this entropy, all this information, and then put it into a pool. And this pool is constantly mixed up with more information, more things, and it's constantly updated. And the overall idea is that when we want to generate then a number, a pseudo number, we want to generate a pseudo number, what will happen is basically we go through some algorithms and we actually have the output that in our case should be a key generation, but in other cases could be nonces, could be IVs, could be many different things. So let's try to understand. So from a high level perspective, what the CS algorithm is trying to do is generating entropy from the device itself. So the device that you own are actually constantly updating the information, and then it's actually showing up a number that is going to be then our seed phrase. What we are doing as Elysium is trying to create entropy from the user and not actually from the device. And that's really important thing, and that I want to stress it out a little bit because it's really different in the way and the implementation that we have. So in one way, you do have the device that is generating constantly entropy. On the other side, you have the user, you as a user, that is generating some entropy for then creating what we have, like the cryptographic key. You can ask maybe why like creating user entropy? Why cannot just use device entropy? Well, the overall idea is that you are unique as a human being, as a user. You're actually unique. Why? Because you have a set of features that are actually unique. Your life is unique, your physical appearance is unique, and in general, all your experience in life are actually unique. And so if you think about it, you are a true random, right? You're a true random number on all the others. And this is really important. That's something that we actually want as engineers and as developers. And so how the question is then, how can we extract the entropy from the user? Well, the answer is we can use the user factor. Okay, so the user factor is something that we're quite familiar. We will go deeper a little bit now in the next slide. But the overall idea is that there are quite a few types of factors in our life. And that's how we think it's the way to extract information from the user. So real simple. So the question is, what is a factor in the 21st century? Well, the short answer is everything could be a factor. I can probably stay like 3 hours talking about factors, but the overall idea is that the long answer is a factor is basically an authentication method where you as a user present your identity to a system, and the system recognize it and say, okay, this is actually you. You can do a specific action on it. What are the standard nowadays? Well, there are quite a few, but the main one are basically these. So you have the password, email password, traditional way how we enter in the web, Face ID if you have an iPhone, but in general, if you have a phone, you're quite familiar with Face ID, and OTP, so one-time password. It's another thing that's really now getting hot nowadays. So the thing is, so these are the standards that we can say are the standards nowadays, but in the 21st century, like factors has evolved, and as technology is evolving, it's actually changing a lot. So we can actually extract more factors from the user itself. Why this matter? It actually matters because, so why actually extracting the user entropy from a user factor actually matter is because, so first of all, the account that you create is really connected to you as a person. It's easy to reconstruct because you cannot lose yourself. So if you set up in the proper way, you will always have all the information on you. And also because you can decide your security based on what you're basically trying to secure. So let's say you're trying to secure $10. Well, that you don't need like 10 factors. But in the moment you are saving and trying to securing, I don't know, $1 million, that's way different, that you want much more security. And so trying to, using like factors, we can tailor our experience based on many different things. So what we do basically is we generate user entropy from some user factors, and the question then is, what can we use as factors? So there are quite a few. I'm just going real fast and I don't want to bother you too much, but the overall idea is that factors in the normal life can be a lot of things. In general, we say that factor has something you know, something you have, someone you know. So there are quite a few options, but the overall idea is that, let's say, something you know, so knowledge factor are password and pins, really easy. I think as you all don't want to stress too much. Modern factor are becoming a little bit modern, so passphrase, pattern lock. If you have an Android, you kind of know what is a pattern lock. There's also like something you have, so smart cards, security tokens, and something that you actually possess. We can also use phones, or in general also emails, because actually you possess the email, you have the smartphone, so you can actually receive OTP on that. And there are quite some emerging factors like NFC devices, Alekos was presenting before, the guy before us, but there's also like Bluetooth and other things that we can use to actually something to show that we own something and we own a specific factor. Maybe the most interesting to me are the biometric one, because as I said, your appearance is actually unique, and so fingerprint is actually something unique, your facial recognition is unique, and also iris scan is something becoming hot by the day also from the Apple provision. So factors are actually evolving, and I do feel like the biometrics are quite the most interesting. In general, you also have behavioral factors like keystrokes, so how you actually basically push the key on your device, your your voice recognition. So we do have, as human beings, a lot of unique features. If we want to go a little bit more for the future perspective, we would also, our heart rate and our brain waves are actually unique in a way. And then we can move to someone so we can use social media verification to actually verify that it's actually us doing something. We can ask some trust contacts to actually do some recovery, account recovery, and we do have also some peer revising system and other stuff. But in general, the people that we know can actually help us to define a factor. There's also the idea on how you interact with the device, because you as a human being are interacting in a device. We are all interacting in a device in a different way. So the way you actually handling, the way that you use it, the way that you actually do the gesture recognition. So there are quite a few things that in the next future is going to be interesting to understand. This is just a funny thing, is that factors can be single, but you can also mix it up all together to try to create your own factor, right? So potentially you can say a passphrase while your voice is talking to the device, while in the same time you're actually clicking on a security token. This is like a trip, but it's just for you to understand that, of course, like factors can be anything. So that's why I said I can stay hours talking about factors. But the overall idea is that it's something that is connected to you. So what specifically we do at Elysium? So now that you have all the three pillars, so you have the seed phrase, you know what is entropy, and you also know what are the factors. So in general, we are creating a keyless algorithm based on multi-factor authentication system that extract the user entropy and connect it to user identity. And this is really interesting because from a high-level perspective, that's how I will try to make a really simple scheme of that. So you have the factors that generate entropy, and the entropy, of course, generate, as we saw, the seed phrase. Of course, as we were saying before, we are trying to delete seed phrase. So this is just from a high-level perspective, just to showing you that actually we can recreate the seed phrase, but the seed phrase is never present into the device, as we will see it now. So why keyless? You will probably have some question like why keyless, why multi-factor authentication, why you're trying to change seed phrase in general. And so the idea is that why keyless? So first of all, the key is reconstructing where you need it, because when you're using the device, when you're using the wallets, the key is not every single seconds needed to do something. We just needed to sign a transaction. We just needed to do some specific action, and that's really important. So we don't actually need to store the seed phrase in the device. As I said, we just need to recreate it once we actually need it. We do have more security from one side, because actually even if an attacker gets access to our phone, well, then they will find basically nothing. They will just find basically no information about you, no information about the seed phrase. They will just enter the application that's empty. And the other thing that I want to stress out, and it's really like an important thing, is we don't want to have a single point of failure. We don't want to the user lose a specific information, and that's basically you lose all your funds. Why multi-factor authentication? Well, it's easier to extract the entropy from the user using multi-factor authentication. There are quite a few customization that we can have. So as I said, depending on how much you're actually trying to secure, you can define your own security based on your experience and your point of view. And you can also try to find the right balance between security and usability, because if you use a factor that are really difficult to use, well, then it's you have more security from one side, but usability just going a little bit no. But from the other side, if you're just, I don't know, trying to secure $10, you don't want to have, as I said earlier, 10 factors or many others, right? Still, another really important thing, no single point of failure. I just want to stress out. And then the fact that it's also connected to the user. So as I said, you cannot lose yourself, and you always be able to recreate the key even if you lose your phone or even if you lose part of the factors. So that's basically, this is what we do. This is what we feel like it's a new paradigm for Bitcoin wallets in general. Why? Because it's fully keyless, so there's no key inside the device. So we're trying to solve the question, where do I store the key? How do I store it? Do I need to give it to the bank? Do I need it to save in a piece of paper? That's not what we want. It's completely keyless. There's on-demand generation. So basically, when you need to sign a transaction or when you need to do some specific action showing that it's actually you, well, then we have a generation of the key, sign the transaction, and that's it. And then we have infinite customization. So depending of what you're trying to secure, what you want to do, or how you want to use it, you can really try to tailor your experience based on your knowledge or what really you want to do. Aron previously was presenting the trilemma. This is a simplified version, but it's actually the way that we think the trilemma was solved. So you, as we said, are unique. You trust different parties. It's not every single one of us. It's different and trust different things. And so this is really important for us. So you have to decide your experience. You have to trust who you trust more. And you can select your own security. So it's really up to you as you want to define your security. So that's what we feel is actually the way to solve this trilemma. So as you can see, all the green points are actually like potential configuration on our with our technology. What this enables is really interesting, because from one side you can actually generate non-custodial wallets, as we are doing. This is actually our first product, and so the security, everything is on your side. So you do own all your factors, you do own the keys, and it's fully non-custodial. But in the future, potentially, it could also open up the door to many other things. Let's say semi-custodial wallets. So maybe you have in a 3 out of 5, just two factors can be sent to maybe a bank because you trust more a bank, or you can use, I don't know, Google to actually own your factors. So we can try to create some scheme of a semi-custodial wallet, because as I said, you can trust whoever you want to trust. It's not on us. We just give you like the technology, and it's completely up to you. And in the future, of course, I'm not just trying to push the custodial solution, but of course, if a specific institution, if a bank wants to actually do custody by themselves, well, they can actually use it and define their own factors on top of their infrastructure. So this is our wallet. This is basically the first implementation of this technology that you just saw. It's the way that we think we can actually try to onboard the next billion users on chain and in general on Bitcoin. As I said, completely keyless experience. Your factors is fully non-custodial. Everything's on you. But the overall idea and experience that you never see the seed phrase, you never have to manage keys in general. So why we do that? As I said, like, we're trying to keep Bitcoin non-custodial. So for us, it's really important. We do feel like Bitcoin was born to actually delete the intermediaries over financial transaction, and we do feel like it's the way that it should be. So not custody by banks, but actually you owning your own assets and doing whatever you want with your money. So that's the way we think. That's the way we think the future will be for Bitcoin. So thank you very much, and hope you have some questions. Yeah, I don't know if you have any questions. You do have some questions. I do see some.
Sorry, I just want to double check that I understood this correctly. In fact, every time I'm going to log onto my wallet, I'm going to recreate the keys, but just I'm going to use the same factors to create the same randomness every time, so I will recreate the same keys. But I have to recreate sort of the keys and the randomness every time I want to log on. Is that correct?
Yeah, so not every single time you log, because the moment you log, you actually generate in, but every single time you want to sign a transaction, basically. So it's depends on you what kind of factors you can define. So let's say at the moment we do have passkey, password, and passcode as the 3 factors. So it's really easy, like as an experience. So yeah, you got it correct.
The second. Hi, congratulations. So the factors are captured through the device, right? So what happens if the device itself is hacked, as we've seen in different scenarios around fraud and so on? And also in terms of the behavioral factors like voice recognition and so on, how do you see the threat of AI systems which are getting pretty close to replicating and cloning these types of things?
Well, that's a really great question. Thank you very much. So in general, as I said, like there's no key, so it's actually keyless. So even if an hacker get access to the phone, well, they will find basically nothing inside. So from that perspective, sorry.
But if the device is capturing the factors from the user and the device is compromised, how do you trust that the factor has been actually captured by the user and it hasn't been swapped or manipulated? Like a kind of a man-in-the-middle attack, but in terms of the capture of the
I got it. Yeah, we always, for sure, that's a great question. So in general, when we recreate the key, right? So when we recreate a key, we always see if it's actually the same user trying to recreate, because actually when we recreate the key, you also have a public key, right? And so we always validate the identity that you create is the same that you created at first. So there's a kind of validation when you're actually creating it. Do you want to say something?
And yeah, the goal is not just selecting the numbers of factors, because the security is not on the amount of factors that you have, but the risk that you have for those factors. So if you want to select 5 factors, for example, but all the same factors are exposed to the same risk, like the device or AI threats or me, so the goal is not to have a lot of factors and that's it, but to mix the right factors to not be exposed to the right risk. Maybe one factor could be hacked, one could be stolen, one could be, you could be kidnapped, of course, but not all of them are exposed to the same risk. So that's the mitigation.
Yeah. I see what you mean. Okay.
No, the question about AI is really interesting, to be honest. Like, it's the fact that it's, even if you compromise part of the factors, still like having let's say a threshold signature is cool, because the user, so the attacker, in order to get all the funds, should basically try to get the threshold of factors that to actually recreate the key. So even if they get your voice, because maybe AI is really good at trying to reproduce things, still they have to get all the others, and if you set it up in the proper way, that it's going to be really difficult. So that's it.
Okay, great, thanks.
Thank you.
Hi. Doesn't this create a problem in recovering the funds if something happens to the original person that created this mix of login factor to create the wallet?
In which way? So the reconstructure is kind of really similar. So because maybe one of the factors is compromised.
No, like for example, I use my fingerprint
Mm-hmm.
and then a seed phrase and the password,
Mm-hmm.
and then I die and my family doesn't have my fingerprint.
So yeah, and so inheritance is something that
Yeah.
will come later. It's not something that we're targeting at the moment. The overall idea is try to make key management easier for now. Inheritance is something to me is really interesting as a thing, but still it's something that maybe can be solved by vaults. So you can potentially put your funds on a vault, and with a time chain or something like this, you can actually unlock some potential like part of your funds. I don't know, on a basically time lock perspective. But still, like, inheritance is something really, really difficult. I see there are quite a few startups that are working on that, but it's not something that we're targeting at the moment for now.
When yeah.
Yeah, it's exactly why we do have like multiple factors. So yeah, instead of just using one factor, you have multiple. So even if you, I don't know, unfortunately they cut your finger, well then you can still reconstruct your key, change the factor that was connected to the finger, maybe use another one. Hopefully you got at least like another one, and yeah, that's it. So I mean, it's the cool thing about having like a multi-factor is really about, even if you lose part of it, you will still be able to actually regain access to it, since it's actually connected to you as a person and not to the device itself. And yeah.
And another not good solution, as Gianmarco presented, is the semi-custodian. It means you can have, for example, one factor could be a bank, so you have an infrastructure behind that is not only on you. So that's, of course, is not pure self-custody, but it's still a solution.
I think you need to have the micro. Sorry, I didn't see that. Sorry.
Just two questions. One is, I just quickly looked at it. So this is a wallet that you guys created.
It's a wallet. So actually, what we do, so the first product is the wallet.
Yeah.
So it's a Elysium wallet, but behind there's the technology that we just presented.
So that was my second question. So, but the first one, this wallet is just Bitcoin, or is it open to?
No. So at the moment it's Bitcoin. So we're a Bitcoin company in general, but we do have Polygon at the moment for stable coins, just because we're from Lugano and we want to have integration with it to see how to pay.
Yeah.
But the overall idea in the future is just to go really full Bitcoin, just because I'm not really into crypto in general. So yeah.
And then if you wanted, but is the tech going to be licensed to other?
Yeah,
That's
wallets?
a potential. Yeah, that's a potential future. We are working on a technology at the moment. By the end of the year, should be ready. But still, we have some thoughts and discussion on the topic. But yeah, for sure, it's going to be maybe coming in the future. But it's still something that we are trying to define.
Which is also in perspective of you raising funds and what the potential of the idea is.
Yeah,
That's
for now we are B2C, and
Yeah.
maybe in the future we'll see maybe B2B also.
Okay,
yeah,
thanks.
what we are doing is building the technology separate from the product. So there is the wallet, and we have the technology. We are also working on the IP side in general protection of that. We have the wallet as a use case, and we are solving the problem that we think is the main problem right now. So the wallet itself and the custody of assets. But this technology is in the authentication markets, not only the Bitcoin side. So we have a really great potential. If you are an investor and we want to discuss that, we have a lot of things to say.
Oh, sorry.
Sorry.
You keep skipping your turn.
For recovery, you need deterministic entropy, right? You need to be able to
Yeah.
make sure that you're able to get the same entropy multiple
Yeah.
times. Is that achievable with like physical attributes? Because I know, for example, Face ID, I'm pretty sure you're not actually generating the same entropy every time. You're just
Yeah.
kind of matching, making sure it's close enough. Maybe your
Yeah.
fingerprint is the same, right?
Yeah.
So
Face
how do
it.
you
Yeah.
make
Sorry. Let's go on.
So how do you make sure you get the same attributes every time,
Yeah.
and they're not changing? Say you get a haircut, right? And you know that in 10 years your voice hasn't changed, and you
Yeah.
can still recover that entropy.
Yeah, so Face ID is not maybe the best example. It's just for you to understand, but of course, like it's facial recognition in general. So your face, the pattern that you have on your face, that's basically the idea. Face ID is just saying yes or no, basically on your device. It's just an example, of course.
Well,
Like
but
we,
still like with prints, and like I'm assuming that I'm not experiencing that, but
yeah.
none of the scan that we're doing with our fingers or anything is actually outputting the same entropy every time.
No, for sure. That's why we're using, for example, passkeys, right? Passkeys are just basically a way for you to get the information that is actually the same user doing that, but from a high level perspective, no. So that's a good point for sure. And what was the second question?
No, but there's only one. I'm just
specifically
specifically on the physical features
Yeah,
that you guys are using, leveraging to.
Yeah, so let's say your voice maybe in 10 years change.
Yeah.
That makes super sense. But at the same time, as we said earlier, similar to the fingerprint example, even if you lose a finger, the same finger that you were using to actually access your phone, well, then you can recreate or use one of the other factors, recreate the key, and change that specific factor that is actually giving you some issue on the recognition. So that's something that we're already thought about.
And do you use that in production today?
What? Sorry?
Do you use that in production today? Like
Not yet. As I said, we just have 3 factors for the moment.
Yeah.
By the end of the year, we'll probably have 5, and next year we're gonna expand way more. So that's for now. That's just the showcase on what we can do. But then for sure in the future we'll have multiple other implementation.
Cool. Thank you.
Hi, thanks for the presentation. That was really interesting. I got 2 questions. So for the MFA, would it require to have all the factors, or could it be a 2 out of 3 or 3 out of 4?
You mean like from a setup perspective?
Yeah.
So yeah, it's completely up to you. So for now, it's a 2 out of 3 basically. So you need to always have 2. But in the future, the idea is really to be as much customizable as possible. So from your perspective, as I said, for now it's just a showcase on what we can do. But in the future, the idea is depending on how much you're trying to secure, or potentially is also something that can grow with you. So let's say you start with Bitcoin, you just buy $10 of Bitcoin, you don't want to have 5 factors, and then in the future you're from $10 you start to have like 10,000, then for sure you want to change the security model on top of that. So it's something that can grow up to you, so you're not really tied to a specific setup. You can change it.
My question was more like, if we make it 2 out of 3, then if we consider the order of the input factors, we would have 6 potential entropy inputs, and if we don't consider the order, it would be 3. So that would mean that 3 or 6, I don't know how you do it, potential different entropies would lead to the same creation of priority.
Yeah, but we don't actually use the order, so that's
3 different input would lead to the same entropy.
Yeah, exactly.
Okay, that leads me to the question is, I really like the concept and I think it's really great and it's new, but I have to trust the way how you come from the entropy to the private key. Is your algorithm open source, or how can I ensure that you're not just doing whatever in the background?
Yeah, the thing is, we are now trying. I don't want to disclose too much because our lawyer will beat us. But yes, we are thinking about all the IP strategy, because of course before disclose everything, because we want to be transparent with user. We have no this is our secret sauce, but we are not villain, so we would like to make it open and more open as possible and make the license, of course. So when we arrive with a good IP protection, we would like to open the doors to everyone to know more, because this is just the algorithm or how he treat it.
Yeah, we are Bitcoiners too, so I know I don't trust I verify. So I do like the idea, but yeah, still it's something that we're working on at the moment.
We don't trust our company too.
So the idea is that you never trust Elysium in general, but you have to trust the way it is implemented. So also because it's the way that Bitcoin works, right? So yeah, thank you for the question.
A great job, guys. It's an amazing product, and I like the idea. You mentioned not having a single point of failure or being robbed or something. So what are the? Could you explain? I must have missed this part. Like, which one of the factors would be not part of you on your physical persona? Because a lot of these were something that if someone puts a gun to your head, then you have your voice, your biomarkers, and your passphrase. Those are all like personal points of failure. But you mentioned a semi-custodial option. So what would that? What would an example of that be?
No, that's a great question. So in general, if you so every single factor, and this is something that we're studying with the guy over there, it's basically every single factor has some threat models, right? So every single factor, for example, your face can be replicated maybe by AI, your voice similar to the question that was asked before. But the overall idea is that depending of so the idea is when you are creating your account, we're giving you some hints on which is the best potential options to use, right? Because of course, if you use every single biometric factor, then for sure like somebody can kidnap you, and that's basically you're done, right? But if part of those factors are maybe outside you, let's say an hardware wallet, maybe let's say as we was saying, security tokens, maybe an NFC that you have at home, maybe a QR, maybe, so there quite a few, of course. So that's where the balance comes from, right? So you do start by this, that is really simple as a concept, but in the future, the idea is when you are setting up your account, you will have information of what are your threats and what are also the benefits, right? So what's your security, but what's the usability? So and then it's up to you and understanding. So am I going to use like Bitcoin every single day because I'm from Lugano? Well, that's, you need to target a little bit more from a usable perspective. But am I just like hodling and just taking my Bitcoin? Well, you can just have more security from the other side.
That's also a UX challenge, not just a technical challenge, and we have really good designer working on it.
Awesome. The second part was just, you guys are clearly raising. What's the revenue model? I don't know if you want to talk about this outside of this or whatever, but just curious on, from an investor standpoint, what's the revenue model, or how do you guys charge it? You B2C, so you charge like a subscription model, a SaaS business, or?
Yeah, from the B2B, yes, it's a SaaS model. So it's a licensing technology that we can sell in a B2B way or
Right,
white
like you
labeling.
mentioned over there with other chains, and that makes sense.
But that's what we are thinking now, but it's not in place yet.
Right.
Now we are just B2C, and you have to see us from a business point of view like a Revolut, Revolut app, but without the bank, peer-to-peer, with our technology for Bitcoin and stablecoin. So the goal is to have on-ramp, off-ramp, exchange and swap between, of course, stablecoin and Bitcoin, buy and sell and so on. We would like to also have a card, a non-custodial card to make payments instantly with exchange in case. We have also a system that we are probably implementing soon that is called intention-based transaction. It means you have Bitcoin, but you have to pay a coffee in Lugano, but you don't have USDT on Polygon. All the things behind to make this payment will be executed automatically. We have an app. We have an app section in the app, and the goal is that in our wallet, not only you can customize the security behind and the onboarding, but also is tailor-made for what you need and use case that you want to have daily. So if you want just to pay, to store, to buy, sell, and whatever, you can do it. But our goal is to make you also move your Bitcoin, not just store. So in the hub, you will have Travala. Probably we are making some partnership that you can spend directly in the app. This is our referral system. So just to wrap up, we have a freemium model because we can have more feature, more security side and whatever. The app is free, everything is free, but we can have a freemium model, fees model on transaction and use cases, and a referral model for third-party services. Or for example, also a sponsored transaction model. It means you make a transaction and you see, oh, your transaction is free with a gas fee and whatever because it's sponsored by Fulgur Venture. So Fulgur pay an ads, we pay the gas fee, and we make also earnings.
I see.
So we are also mitigating the risk of our company point of failure while having many revenue streams.
Thank you.
You're welcome.
Hello. Great presentation, sorry.
Thank you.
My question is, when you collect these factors, do they go to a central server to calculate the hash, or it happens on the device?
No, everything is locally. So
the device.
Also because it would be another point of failure potentially. So no, for sure, it's everything happens locally, and yeah, so nothing goes outside your phone. That's okay. I don't see any other hands. Raise hands.
By the way, download the app. Now you have to try it. It's available in almost 30 countries. I don't know where you're from. We would like also to expand the next 10 countries in developing countries, Asia, Africa, and South America, because of course the use of Bitcoin is really needed there. So if you want to download, give us a feedback, 5-star, could be great. Our investor will be happy. So thank you.